In this video, we're going to look at solving trigonometric equations using the angle addition formulae and the double angle formulae. So on our sheet here, we've got the angle addition formulae, so the formulae for sine A plus B, cos A plus B, and tan A plus B, and of course the double angle formulae, which we don't get given in the formula booklet, but we can derive those from the angle addition formulae. Now, we're going to look through two examples. The first of these is going to be one where we're going to use the angle addition formulae, and then we're going to look at the double angle formulae a little later on. So our first example, we're being asked to solve 4 cos theta minus 30 is equal to 8 root 2 sine theta in the interval 0 to 360. So the first thing we can recognise is we've got here cos of theta minus 30. So we're just going to write that using the angle addition formula for cos of theta minus 30. So I'm just going to rewrite that equation. So I've got 4 lots of cos theta cos 30 plus sine theta sine 30, and that is equal to 8 root 2 sine theta. So straight away we've got a few things we can spot. I've got a 4 here and an 8 here, so if I divide everything through by 4, we've got cos theta cos 30 plus sine theta sine 30, and that is equal to 2 root 2 sine theta. So I've just done that division by 4 at this stage. So now a couple of other things we can spot. Cos 30 is root 3 over 2, and sine 30 is a half. So I can write this as root 3 over 2 lots of cos theta plus a half sine theta is equal to 2 root 2 sine theta. And now I can bring everything with sine theta on to one side and everything with cos theta on to the other side. So I can subtract the half sine theta I've got here from both sides. So I've got root 3 over 2 cos theta is equal to 2 root 2 sine theta minus a half sine theta. I can then factorise this right hand side. So root 3 over 2 cos theta is equal to sine theta lots of 2 root 2 minus I've got an expression and that would give me that theta is equal to 20.4 degrees. So that is one of our solutions. if I just look back at the question, we were asked to find the values of theta between 0 and 360, and tan theta repeats every 180 degrees. So we have another solution by adding 180 degrees to what we've got here, and that would give us 200.4 degrees. And that there is another solution in the interval that we were given. The second example we're going to look at is one where we're being asked to solve 3 cos 2x subtract cos x plus 2 is equal to 0 for x lying between 0 and 360 degrees. So in this instance, we've got a cos 2x. So rather than our angle addition formulae, this is telling me that we are going to use a double angle formula. So if we look at our double angle formulae for cos 2x, it's given as cos 2a here. We've got 3 different options that we can use. We've got cos squared a minus sine squared a, we've got 2 cos squared a minus 1, and we've got 1 minus 2 sine squared a. And if I look back at my question, we've got cos 2x, we've also got something in terms of cos x. So it makes sense logically to choose the double angle formula, which is going to express things in terms of cos x. So I am going to first write this as 3 lots of cos 2x is equal to 2 cos squared x subtract 1. So that's our use of the double angle formula. And then I have subtract cos x and plus 2 is equal to 0. We can then expand out this bracket. So I've got 6 lots of cos squared x subtract 3, subtract cos x plus 2 is equal to 0. We can collect together the negative 3 and the positive 2. That's going to leave us 6 cos squared x subtract cos x subtract 1 is equal to 0. And hopefully we can see that we've got this in the form of a quadratic, because we've got cos squared x, we've got cos x, and we've got a constant term equal to 0. So I can let u equal cos x, which means this becomes 6u squared subtract u subtract 1 is equal to 0. This is one that we can spot factorizes, because I can write this as 6u squared subtract 3u plus 2u subtract 1 is equal to 0. And then in factorizing each half, I've got 3u lots of 2u subtract 1 plus 1 lot of 2u subtract 1 is equal to 0. So 3u plus 1 lots of 2u subtract 1 is equal to 0. Therefore, this first bracket gives us a solution u is equal to negative a third, and the second bracket gives us a solution of u is equal to a half. Now we need to remember that we said u was equal to cos x, therefore that gives us cos x equals negative a third and cos x equals a half. And to find our values of x, we need to do inverse cos of each of these. So inverse cos of negative a third in our calculator gives us that x is equal to 109.4 degrees. And if we consider the symmetry of the cos graph, there's also going to be a solution at 360 minus 109.4. So I can do 360 subtract 109.4, and that's going to give me another solution of x being equal to 250.6 degrees. Using x, or cos x is equal to a half, I can do inverse cos of a half, and that is going to give me that x is equal to 60 degrees. And then I can also do 300 subtract 60, again because of the symmetry of the cos graph, and that is going to give me x is equal to 300 degrees. For more GCSE and A-level maths content, subscribe to N Jackson Maths on YouTube.